Folks, well, good afternoon and welcome very much, and thank you very much for coming to our first TESS seminar of the semester. As you all know, I'm sure TESS stands for the Center for Tropical, Environmental, and Sustainability Science. One of the happiest things I've ever done is to come up with an acronym that you can say in one word. Try saying Center for Tropical Biodiversity and Climate Change 5 times fast and see how that goes. Anyway, we have a weekly seminar here. We're very, very pleased to have undergraduate students as well as our usual assortment of postgrads and postdocs and faculty members and adjunct researchers and others. I want to point out a couple things that TESS we're trying to do for folks here, for our associated researchers. One is that we have a part of our website. Please do check out the TESS website because there's a section in the TESS website called TESS Opportunities, and it's got all kinds of jobs, postdocs, faculty positions, research opportunities, grant opportunities, just tons of stuff that we just continually keep populating that page or that whole section, and it's worth checking out. Another thing that we've done in the past, and we really want to ramp up again, is this idea where we're trying to help make you famous as researchers, and that's part of our job. So anytime you publish a paper or you get named in a newspaper article or anything like that, or you get a nice talk, like a high profile talk, or you get a cool grant, send us, just flick it to us. That's all you got to do. Here it is. And we'll take it from there. We will tweet it. We will distribute it through our social networks and that type of thing. And it's really good for you. And then the final thing, again, in our sort of the spirit of trying to encourage as many undergrads as possible, we're going to have door prizes. This is something that Yoko and I think maybe Nina invented. But anyway, there will be cash door prizes. We had thought about alcohol door prizes, but anyway, cash door prizes for 2 students every week, starting next week. So that's a good thing. And now it's, oh, and sorry, I guess I have to, before I introduce Penny, I've got to do a couple of other things. We have to have our acknowledgement of country. So I'll just quickly read this. We acknowledge Australian Aboriginal and Torres Strait Islander people as the first inhabitants of this country and pay our respects to the traditional owners of the land on which we stand today, the Jibugai, Yuradanji, and Jimu Yidinji people. In the spirit of reconciliation, we also acknowledge the valuable contribution that Australian, Aboriginal, and Torres Strait Islander people continue to make to James Cook University and the broader community. So anyway, it's a pleasure now finally to introduce Penny. Sorry, we're not normally quite this long-winded, but it's first one of the year. So Penny is one of our adjunct faculty members. She has a doctorate in ecology. She considers herself an ecologist. Penny does a lot of work in the space around environment, climate change, restoration ecology. Yeah. She's a very
How
much.
How are others going to get into the?
She's very much a big picture thinker.
All right.
No,
that's true. All right. Thank you very much, Andrew. I mean, yeah. Thank you. Okay. Bye bye.
That name. That's a familiar name. I mean, voice. Anyway, as I said, Penny's into climate restoration, carbon credits, carbon trading, a lot of those kinds of things. And her, along with her husband, Noel Priest, they have a very nice, about a 30 hectare or bigger than that, but they're trying to restore 30 hectares up on the Atherton tableland. Penny's won a lot of different awards, Eureka prizes, Whitley Awards, Mulvaney Awards, a lot of good things. So anyway, I'll turn it over to Penny. Apologize for taking so long, and thanks very much, folks.
My respects to rainforest country and peoples, past, present, and emerging. Cloudland, whoa, okay, so we haven't got the slides. Cloudland's a story of a patch of rainforest at the head of Thiaki Creek, the very first runnels of the Johnstone River. Interwoven with this story is my own experience with Thiaki during a restoration of a 50-hectare paddock. The book pleats and folds through time, evolutionary, dreaming, historical, forever, and contemporary time. And here's a taste. In a way, I was ambushed by Thiaki. In 2004, we came to inspect the property I'd found on the internet, and we arrived at the back of a house perched on the edge of a volcanic ridge. Walking inside, we were suddenly confronted through the large window by a jungled landscape hidden until then. The forest was breathing, blowing out a play of shapes and forms. So this sentient landscape could be ours for the short microbial. Oh, my son. Sorry, the grandkids are right. This sentient landscape could be ours for the short microbial life left to us. That really threw me. Thiaki is a scrap of cloud forest, the northern section of a larger 1,000 hectare patch, the largest privately owned remnant left on the Atherton tablelands. It's a known hotspot for tree kangaroos, the ringtail possums, and all 13 endemic species of birds of the wet tropics. Thiaki overlooks the paddocks of the Atherton tableland at 1,000 metres. The owners called the place Ups and Downs, and much of the land like this was up to shit, according to settlers of one of the last areas opened for clearing in 1954. He had to hang on to tree trunks as he was brush hooking around steep hills all the while it was raining like hell. The same settler wrote in 1979 that you needed a fistful of dollars, a big heart, no brains, and a bloody big umbrella to farm this country. He wished he'd walked off it in 1954. The soil was marginal for farming, and once cleared and burned, it reverted to a maelstrom of weeds. All but 4% of the 80,000 hectares of the rainforest of the Atherton tablelands were raised in pursuit of an ideal of closely settled farms with rosy-cheeked children and plump wives. Thrilled with the place, we bought it. Our 180 hectares comprise 130 hectares of log but intact forest and a precipitous 50-hectare paddock. With value measured in cows, we'd struggle to make a living, even though the rainforest was amongst the most biologically valuable pieces of land in the world. At best, we'd receive $5,000 a year adjusting cattle. While it hadn't been easy to turn a lush tropical rainforest into paddocks, how could you turn paddocks back into a rainforest? Community restoration efforts have relied on tokenistic government funds to plant dense stands of native seedlings in pursuit of an almost instant closed canopy. At 60,000 a hectare, it's no surprise that only a few tens of hectares have been planted, with most grants going to more cost-effective restoration elsewhere. It's not the landscape scale change that is desperately needed to restore the wet tropics to any semblance of its former glory. We put up some money and leveraged an Australian Research Council grant to look at cost-effective restoration using a mix of species that would maximise biodiversity while providing an income through carbon sequestration. On the 28th of January 2011, a bunch of academics and a crack team of planters assembled to build the foundation of such a rainforest with 30,000 plants. The date was important. Records implied rain would be a given and the ground would be guaranteed to be wet. But as the week progressed, the sky became clearer and the days hotter. Something was sucking away our weather. A day after the last seedling went into dry ground, severe tropical cyclone Yaki, Category 5, and one of the biggest cyclones ever to cross the coast, roared over the Coral Sea and over Thiaki. One of the first things you notice about Thiaki are the clumps of mosses hanging like scruffy beards on the trees and giant mosses carpeting the ground. These deceptively humble bryophytes are in fact the ancestors of the towering forests of the world. It's quite an ancestral story, cell-sized micro beings creeping slowly and inexorably onto barren land, morphing over unimaginable periods of time into forests. The evolution of plants and the creation of the atmosphere are intimately linked. As plants grew and died, organic material was buried and the oxygen was produced as a byproduct. 400 million years ago, bryophytes had already formed the first carbon exchange system of the world, a mycorrhiza with semi-aquatic fungi, which couriers hard-won nutrients from the hostile rock directly into the bryophyte cells in exchange for carbon from photosynthesis. The very evolution of plants is possible only because of this ancient kinship amongst living things. The Yaki's paddocks of sun-blasted soils, leached of nutrients and monopolised by grass, were in a state of arrested evolution, an expression that surely captures the essence of the Anthropocene. Miraculously, Yaki's fury barely touched the newly planted seedlings. Quite ironically, it was the irksome grass that saved the day. We'd left the grass between weed-sprayed rows of young seedlings to reduce costly pesticide use and protect the soil microbiome. And the grass had blown over the seedlings, shielding them from the 250 km/h winds. In 2014, we noticed that on steep slopes, the Flendersia were sickly. Young trees were spindly and jaundiced. Where the slope flattened out, they were lush, green and growing fast. It's just one species. The Cardwellia sublimis, a Proteaceae, however, were robust and bounding up the slope with no difference in size. We thought it might have something to do with the mycorrhiza, and so we investigated this with colleagues who are here today. Flendersia is reliant on mycorrhizal fungi for nutrients. It turns out that our overgrey slope-wash slopes are too depleted even for these highly evolved relationships. Where the nutrients are washed downslope, they are taken up by the mycorrhizal fungi into the healthy trees. Cardwellia has improvised a different path and fashions the plant roots themselves. When nutrients are low, super rootlets erupt from the main roots in dense clusters growing quickly in a matter of days, bursting and releasing organic acids that etch out the nutrients tightly bound to the soil. Life clearly loves to improvise. Plants' frenzied evolution vented oxygen, which fueled a revolution in the sea that spilled onto the land when the first tetrapods emerged 400 million years ago. These amphibian labyrinthodonts, like an axolotl with a bigger head and razor-sharp teeth, lumbered about covered in mites and ticks. Surprisingly similar to the one that nearly killed my husband Noel a couple of years after the Yaki planting. He developed a severe pain across his upper back. And when I took him to hospital, the doctor said he'd had a heart attack. I said I doubted that, but that they should look at the angry eschar around a tick bite that had formed on his shoulder. But his heart was pumping out specific cardiac distress hormones, and he was rushed to Cairns, where they indeed found that he wasn't having a heart attack. But his heart was nevertheless swollen in response to a bacterial rickettsia infection carried by ticks. Let's stay with rickettsia for a bit. 600 million years ago, it was a free-living bacteria in the Ediacaran Sea, where the western part of Australia lay in the northern hemisphere, beginning a slow waltz to the South Pole. Eastern Australia was being driven up by the tectonic collision with the early Pacific plate. It was on this journey that Thiaki was thrust out of the sea and upward to a few thousand metres 360 million years ago, by which time Australia had drifted to the South Pole. On the edge of the ice sheets, new plants were already innovating protective coats for sperm called pollen and special leaves enclosing female eggs. Around 300 million years ago, Glossopteris forests with cycads became the signature forests of Thiaki. The tetrapods that ate the cycads back then must have had a legendary constitution, because the seeds contain a neurotoxin that damages the brain, destroys the liver and causes cancer. At the time, synapsids, the precursor to mammals, were the dominant creatures. Some were hippo-sized herbivores that housed enormous fermenting stomachs, and they got around in great lumbering herds to reduce their chances of being eaten by the fierce synapsid carnivore, a pattern woven into the fabric of life to this day. Herbivorous synapsids gulp down masses of fruit without chewing the nut. Perhaps the strangest of all creatures to eat cycads are the comparatively, so that's the scene from that time, perhaps are the comparatively delicate synapsid called humans. Joseph Banks in 1770 noted the plentiful crop of nuts around Rainforest People's fires. When his sailors ate them, Banks said coolly they were deterred from a second experiment by a hearty fit of vomiting and purging. The ship's pigs died when fed the nuts. Rainforest women knew about the process of detoxification, intimately wielding the elements of legend, fire and water. They carefully gathered selected nuts, which were roasted and then grated into a flour and then sifted through a palm fibre dilly bag, after which the fibre paste is carefully folded into leaves and placed into running water for days. 300 million years ago, you could walk from Siberia in the North Pole to Australia in the south, across this supercontinent of Pangaea. Australia lay in slanting polar light, though temperatures were mild in the mid-20s. There's nothing remotely like that today. Life was in top gear with synapses in the ascendancy. The Yaki was set within a mountainous landscape of broad valleys, coral-encrusted bays. Insects would follow the plants, and there were 27 orders, much the same as there are today. Amphibians occupied an abundance of niches, and archosaurs, the ruling reptiles, were abundant but not yet ruling. But then came a devastation so great that it very nearly annihilated all of it. Extinction events are the hallmark of life on Earth. There have been about 17 of them since life exploded in diversity. That's about 1 every 30 million years, though they're not that evenly spaced, and there's only 5 that nearly destroyed life, 6 if you include ours. Of all these, the Permian of 250 million years ago was the greatest. So just take that in. It slammed shut the entire period of old life, the Paleozoic, that lasted 300 million years. Nearly all life disappeared in the sea, which must have looked like the dead zones of today's Baltic Sea, Chesapeake Bay, Lake Erie, and the Gulf of Mexico. On land, 70% of life was obliterated. It's not entirely clear what caused the Permian extinction, but the rough outline is that a colossal plume of magma, think of the size of a planetary moon, say a small moon of Jupiter, rising from the Earth beneath Siberia, setting off blasts of billions of tons of gases. Acid rain from the sky, and ozone was destroyed. The land was irradiated. Temperatures in the ocean spiked to 45 degrees, so a relaxing soak in this sea would have induced heat stroke. Signals locked in plant stomates, like a message in a bottle, showed CO2 levels from 400 parts per million, like today's, rocketing to 8,000 parts per million. It took millions of years to recover. In the sea, there were 10 million year coral gaps, and on land, 10 million year coal gaps. Bowen Basin fossils show the land reduced to a slimy mire of weedy plants with amphibians and plague numbers of synapsid Lystrosaurus in places comprising nearly the entire fauna. Forest collapse, ocean acidification, continent-wide stratospheric puncturing superstorms, heat waves and massive wildfires are all hallmarks of planetary destruction. It sounds eerily familiar, and soberingly, this, the greatest of Earth's extinction events, has its best analogue in today's Anthropocene. After major extinctions, life begins in the Lilliputian world because only the small and fleet survive. Inevitably, life lurches onto a different track. The reptiles, which had been widespread but skulking in the synapsid background, now took over the world. Mammalian Lystrosaurus was replaced by reptilian rhynchosaurs. Darting in the shadows were light and graceful dinosaurs who emerged to thrive with the other archosaurs. When the birth of the Atlantic Ocean spilled titanic flows of magma, it sealed off the Triassic and ushered in the Jurassic, vanishing most of these archosaurs, except the dinosaurs who emerged triumphant from the 600,000 years of chaos. Pangaea began to disintegrate. The Pacific plate continued to plunge under Australia, and the wet tropics rotated into slightly lower latitudes. Blemishes on fossil plants show that the Jurassic was literally buzzing. The plants were already nibbled by evolved beetles and katydids, pierced by bugs, flies and wasps. Cockroaches munched the litter. Frogs had dragged themselves through the end Permian killing time, and by the Jurassic, it was a noisy place once again. Life as it does was once again filling Earth's ample niches. Hidden from the rambunctious dinosaurs were the early mammals, oozing into novel ecospaces not occupied by reptiles. They were nocturnal, arboreal, fossorial, and they evolved in bursts of evolution seen by the 4,000 fossil genera of mammals compared to 547 of the dinosaurs. Thiaki's forests were rich with as many as 200 species of plants, including araucarian species similar to today's bull kauri. But where were the flowers? They were absent from the fossil record and seemed to burst onto the scene almost miraculously in the early Cretaceous, as if by the hand of God. It was too much for Charles Darwin, who was in the process of murdering God with his idea of evolution. Darwin, as usual, was correct. It was a poor conjecture. There's a view that by the time fishes had heaved themselves out of water about 370 million years ago, plant innovation was already done and dusted. There were already water-conducting cells, early leaves and roots, and sporangia would evolve into seeds. Darwin's last words on the matter in 1881 were that he fancied that the development might have slowly gone on for an immense period. In fact, molecular evidence and new models strongly suggest a long fuse evolutionary history. It's even possible that the specific seed plant that would spawn both angiosperms and gymnosperms had emerged as far back as the Devonian, when Thiaki still lay under the sea. A few years ago, a brief botanical survey of Thiaki's trees produced a modest list of 220 species, nearly all flowering. Not many, but what is extraordinary is the presence of so many ancient lineages. Thiaki's subset of plants mirrors the World Heritage quality of the wet tropics. This description is a bit misleading because it implies that flowering plants evolved from gymnosperms, which they probably didn't. One of the oldest flowers on Earth is a liana named Oosterzee scandens, which has made it through at least 120 million years to climb and loop along the edge of our back deck. Evolving before bees and butterflies, it is attractive to flies, emitting a rotting odour, not unlike the pungent farts of our cattle dog. Oosterzee evolved to live with dinosaurs. Under constant threat of being ripped in half, it has built-in bayonet joints that quickly disengage and readily resprout from snap stems. Dinosaurs didn't appreciate flowers, who simply kept their heads down. The dense, multi-storied forest that we know today, with large seeds and fruits and a closed canopy, emerged only with the demise of the dinosaurs at the end of the Cretaceous 66 million years ago with the Chicxulub asteroid. The clearing mania of the first 2 decades of the 20th century brought about the near extinction of the Marby forest, the main upland rainforest type on the Atherton tablelands. Nearly all of it was razed. Thiaki lay adjacent, scarred by logging and brooding over the Holocaust. It was as if an asteroid had hit the place. The forests were erased to establish order in the landscape, with its thousands of closely settled and smiling homesteads, a future enshrined in government policy. When the asteroid hit, it punched a 2-kilometre hole in Earth's crust, ballistically ejecting sediment into space at greater than escape velocity. The immediate blast levelled trees within a radius of 1,500 kilometres. Extinction wasn't random, with large species toppled by a global heat pulse followed by the blistering cold of an impact winter. Survivors were once again Lilliputian. Birds were ground-dwelling or aquatic. Mammals were small or burrowing. Nevertheless, millions of years of evolution would spin its magic on this eclectic bunch. Modern humans have inherited an incomparable variety of life, a richness brimful of possibilities, never before seen in Earth's 4.5 billion year history. It's not dissimilar to the Aboriginal perception of ancestral time, which, according to Deborah Bird-Rose, is ecology on steroids, life flourishing through looped and tangled benefits, mediated through earth, water and air, a potent power with us always, sustaining and maintaining the world, an ever-present condition of existence with no limitation of space or time. Uncannily like evolution, the description is deeply philosophical. We, alongside all living forms, are part of the process. But this cosmology comes with a sting. If we fail it, it will fail us. It was 1986 when wildlife ecologists finally looked at the Atherton tablelands, and the view was of a rainforest scrapyard. Extinction has a cruel dynamic. Small fragments below a hectare will lose their rainforest species in under 9 years. Medium-sized fragments around 30 hectares will lose their mammals in 3 decades, and large 70-hectare fragments will lose theirs in 60 years. At least 300 hectares is needed to keep lemmuroids for a century. We would need to fully restore a third of the Atherton tablelands to keep rainforest mammals for the next millennium. The Anthropocene is grotesquely unique. Refugia were crucial to the survival of life after other extinctions. Deep valleys, rivers and lakes, coastal regions and in the tropic sheltered spaces. Today, all rivers, valleys, lakes, coasts and the forest in the world are fully exposed to my extinction shockwave. Geologically, my extinction event is happening in an instant. At the current rate of clearance, all of the forest of Earth will be gone in around 100 years, and with them, most of the vertebrates. The Marby forest that was once continuous across the Atherton tablelands will never return. Even now, the last vestiges are being scraped away, leaving only scraps, ecological zombies. Still there, but not significant for ecosystem function. From this point of view, our restoration effort is a zombie buster. From the main Thiaki remnant, the view to the north and east is of rolling emerald fields. Tourists often stop near our driveway to take a picture of the bucolic outlook. But fallen with the trees from this picture-perfect view are the Rainforest People. The wet tropics is the home of at least 20 Aboriginal groups, 120 clans and around 8 languages. The Nadjin people who inhabited Thiaki had mind mapped and named every conceivable aspect of the place, every boulder, waterfall, tree flange, gorge, valley, riffle and ridge. Would have had a story associated with a spiritual ancestor. More than scenery, it is an inhabited geography, each feature luminous and numinous. Country remains for many a sentient landscape, as Thiaki does for me. Ernie Raymond is the senior traditional owner of Thiaki. Ernie's totem is the Lumholtz tree kangaroo, known as Marby to the Nadjin people. Tragically, Nadjin creation stories were mostly swept away, victims of the Australian War. Perhaps terrified of deadly retribution, Ernie's grandmother, Molly, the last Nadjin person to be born in the forest, was reluctant even to speak the language. An important ceremonial ground, Geelan, behind a milking shed of a dairy farm, was the site of the massacre of Molly's clan. Here, around the turn of the 20th century, not that long ago, as payback for the murder of miners who were raping Nadjin women, the entire clan of Nadjin men, women and children was mustered by the police and shot. Creation stories and science can bleed into one another. Perhaps a poor substitute for Ernie's lost creation story is the science story of Marby and its ancestral world. In Cloudland, I use it to trace the Cenozoic. I read it to Ernie and he found it as complex and fantastical as I do. It involves a global marathon, battling brutal climate change, an earth-shattering asteroid, the pull of Jupiter and Saturn, supervolcanoes and predatory monsters. The oldest ancestor of marsupials is found 125 million years ago in China, then clustered with North America and Europe. At the time, it would have been difficult to tell a marsupial from a placental, but for some metabolic reasons, marsupials were hard hit by Chicxulub. Only those that migrated away to South America and beyond survived. As they pushed deeper into polar latitudes, they came across the rising transantarctic mountains, which 55 million years ago soared to 6 kilometres and were perhaps the most formidable barrier on Earth. Can't really see that arrow, but animals slogging their way towards Australia through the tall pine and Antarctic beech forests had to brave polar temperatures that, while higher than today, were still chilly. Small and fleet, they would have had the ability to climb trees and to use torpor to conserve energy, something nearly half of all marsupials still do today. Australia had torn an ocean-filled rift valley between it and Antarctica, and these hardy critters stumbled across the last remaining scrap of land near Tasmania. Marby's 55 million year old Eocene world can be seen in a hole in the ground on a farm near Murgon in southeast Queensland. The Tingamara fossil site has produced a suite of intriguing animals. The oldest Australian marsupials, shrew-like marsupials from South America, the oldest bat, and intriguingly, the first placental mammal in Australia, making a lie of the idea that placentals will always outdo marsupials. The site also contains the oldest passerines. Across the fat belly of Earth, another ancestor had burst onto the scene in the wet and hot climates that mark the Eocene. Primates. Resembling tiny tarsiers, they let through the trees of the northern hemisphere. You meant to laugh. Like the animals of Tingamara, primates flourished through the brief interval of global warming, which sent temperatures soaring to 8 degrees higher than today. While the event lasted 20,000 years, it heated the planet for the next 200,000 years. But the forest that cloaked the Earth from pole to pole mopped up the carbon dioxide and Earth began to cool once again. Rainforests ebbed and flowed across Australia like a tide around slowly emerging islands of sclerophyll forest. The old Gondwanan rainforests, however, doggedly tracked their cool and wet conditions of the birthplace and moved up mountains like the wet tropics. Here, on one of the western flanks of Bartle Frere, lives a cluster of giants, Stockwellia, sister to eucalypts, and only described in 2002. At Tingomara time, Thiaki was a multi-layered forest with plant species from the same families we planted in our restoration plot. New species were being soaked up into the Chicxulub's empty niches as if there were no tomorrow. Thiaki's canopy closed for the first time ever in the dinosaur-free environment, and plants invested in larger fruits. The marsupial split into 4 orders. It's Marby's story, so the focus is on Diprotodontia. Kangaroos separated from the other 3 Diprotodontas and came down from the trees 50 million years ago in the form of a small potoroo animal like rat kangaroo, Hypsiprimnodon. I have to mention that marsupial moles also started its career as a bandicoot and probably scurried around in Thiaki's litter. Fast forward 30 million years, and if the eye-popping fossil fields of Riversley are anything to go by, then Thiaki was an amazing place. Over 60 species of animals hung around in the trees, including dozens of koalas and possums. Stalking the forest floor were marsupial lions and micro-lions, essentially carnivorous wombats, thylacine quolls, devils preying on nervous potoroos, and strange, now extinct mammals with no clear affinity, Weirdodonta and Thingodonta. The world's songbirds were also tuning up for a global takeover across the promontory of the Sula Spur, which appeared like a spectacular evolutionary yellow brick road off the northwest of our supercontinent. These were the glory days of Thiaki, and were probably the response to another volcanic event, this one associated with the Yellowstone hotspot. Earth was also being pulled by Jupiter from a circular orbit into an elliptical one, where for part of the time it swung close to the sun, warming the planet. Across the other side of the world, our ancestor had split from gibbons and was hanging around the trees of Uganda with dozens of other species of apes, more concerned with the next meal than the pull of the gas giants that were shaping its evolutionary path. Back in Australia, the rainforest was expansive, rich and stable, and niches were finely divided and full. Today, this sort of wonderland is only found in the remnant rainforests of Borneo, now rapidly being cleared for oil palm. But then, a number of things happened. South America broke with Antarctica, unleashing an icy current that spun around the continent, freezing it. Africa collided with Eurasia and India with Asia, throwing up high icy mountains. The Earth tilted away from the sun and by 7 million years ago was cooling fast. Australia ploughed into Southeast Asia, blocking the warm flow between the Indian and Pacific Ocean. New Guinea was squeezed up, causing a rain shadow on northern Australia. Ancestors of kangaroos and wallabies went yippee and bounded into the expanding sunny forest, leaving the shrinking rainforest, the Hypsiprimnodon. One small paddy melon, think of an arborek or a yellow-footed rock wallaby, continued to graze around the forest, climbing small leaning trees. 10 million years ago, they went back to the trees as modified kangaroos, tree kangaroos. For a brief time in the Pliocene, 5 to 3 million years ago, the Earth warmed again when the ocean gateways between North and South America cracked open, letting warm ocean currents flow around the world. Atmospheric CO2 was 400 parts per million, like today, but with one big difference. The wholesome and unfragmented landscape triggered not extinction, but a radiation of species, and Thiaki returned to its glory days. Marby's relatives evolved into many different species of tree kangaroo found across Australia, the largest of them the size of a small brown bear near Birdsville. Over the wide Ethiopian plains, our common ancestor with chimps had appeared. But it was a short-lived glory moment, and the oceanic gateway shut again. Then all it took was the cosmic flutter of a butterfly wings, the way the Earth wobbles on its axis, to set up the climatic yo-yo of glacials and brief interglacials that mark the Pleistocene Ice Age of 2 million years ago. In Australia, glacials cause dry, cold, windy conditions. Tree kangaroos mostly vanished, except for here in the wet tropics. It was only then that Ernie's countrymen, the Lumholtz tree kangaroo and its sister, the Bennets, evolved in shifting rainforest landscapes. Half a world away in Africa, an auspicious long-legged, ground-dwelling, upright ape emerged, Concepts of Africa and Asia were, of course, meaningless to this savanna specialist, and Homo erectus instead followed a savannistan from West Africa through the fertile Indus Valley, through the richly wooded foothills of the Himalayas and down into Southeast Asia, where they came across a land where Borneo and Java were exposed as a mainland. Here, 1 million years ago, the scene was more akin to out of Africa, with tigers and leopards and Homo erectus preying on herds of stegodon, hippopotamus and antelopes. East of Java, the world's biggest oceans were attempting to churn through channels as narrow as 2 kilometres. Animals attempting a crossing rarely survived. Those few that did landed on strange new worlds with strange island faunas, elephants, miniature elephants and giant lizards. Subjected to the pressures of island life, humans also dwarfed into new species, such as the tiny Homo floresiensis of Flores and Luzonensis of the Philippines. Back in Africa, another peripatetic human emerged around 700,000 years ago, the Neandersovans, the Inter-Neanderthals who lived mainly in Europe, and Denisovans who travelled to Siberia and beyond. Australia became a land of open forested plains and woodlands. Rainforests thrived, but as coastal archipelagos, with leopard-like Thylacoleo, 500-kilogram Palocestes, and Diprotodon, which may have stomped through the forest like forest elephants. In Africa, the climate suited hominins. When groups of contemporary humans emerged around 250,000 years ago, they interbred with Neanderthals and Denisovans, who themselves had interbred with Homo erectus, raising the question of how many species represent humans. By the time contemporary humans reached Southeast Asia, Homo erectus had been extinct for 40,000 years, succumbing to the rainforest environment of the last warm, wet interglacial 115,000 years ago. But even then, when contemporary humans got to Southeast Asia, they didn't find a terra nullius. Another modern human, Asian Denisovans, had got there and had been there for millennia, long before the extinction of Homo erectus. This was the unexpected recent reveal of Papuan genomes which show New Guinea as the red light district for humans. Even more extraordinary, interbreeding wasn't from one Denisovan group, but from 2, separated by 80,000 years. These 2 deeply divergent and geographically isolated Denisovans apparently never met, but they each interbred with new waves of modern humans. It's a monumental whodunit, or more correctly, who was doing it. In this astounding picture, can we even be sure that contemporary humans were the first to reach Australia? One thing is certain, settlement of Australia 65,000 years ago wasn't accidental. Australia needed a minimum of around 1,500 people to make a viable population. Genomic signatures point to one colonising event where the New Guineans took the northern route and Australians the southern. People then slowly filtered across the landscape, building knowledge and coevolutionary culture. Pleistocene people already had a deep culturally transmitted knowledge of plant use. In both Arnhem Land and in Borneo, people were preparing the same plants, yams, palms and canarium. Unlike Homo erectus, contemporary humans found rainforests no barrier to living. Based on an intimate knowledge of life, people used hunting and gathering strategies that were self-evidently sustainable in Borneo, in Sri Lanka and in Australia. After diffusing across Australia, strong, deep splits in the genetic structure confirmed that people stayed put, oozing into their respective landscapes, locking in an extraordinary 50,000-year geographic fidelity. This deep, forever relationship with landscape, culturally expressed through coevolutionary attachment to country, is intimate, almost cellular, allowing people to survive embedded in their sentient landscape through the extremes of climate change. There wasn't a place for the faint-hearted. A rare find of fossils in the headwaters of the Fitzroy River reveal a sharp-toothed fauna dominated by marsupial lions that hunted on the many species of kangaroos, thriving on the growing grasslands. Giant freshwater quincana dwarfed saltwater crocodiles. 7-metre-long megalania stalked the woodlands, dripping saliva as they ran down weakling in herds of horse-sized palocestids and diprotodontids. But then, around 48,000 years ago, there were diabolical droughts associated with El Nino. Megafaunal extinctions in the Great Barrier Reef catchments coincided with this deterioration. Lake Eyre Basin felt the impact. First, its great megalakes shrinking to salt, then the Murray-Darling Basin, then the Fitzroy Basin. The saltwater crocodile survived in viable coastal habitats while the freshwater monsters disappeared with their habitats. By about 40,000 years ago, the rainforest had shrunk into the valleys. Grasslands, the key of herbivorous megafauna, shriveled under the sustained El Nino drought, starving the dependent megafauna. When grasslands made a brief comeback 5,000 years later, the megafauna had vanished. The first people to view the Great Barrier Reef from the coastal ranges would have seen a mesmerising expanse, not of sea, but of plains, filled with a patchwork of savanna, rainforests, and massive freshwater lagoons. The Great Barrier Reef was high and dry, and the wet tropics weren't wet. The climate was cooler, and there were regular volcanic outbursts on the tablelands. Aboriginal people recall that the sea was at the outer edge of the Great Barrier Reef, marked by a steep cliff plunging down into the ocean at the continental shelf. On the tablelands, there are remarkably accurate stories of the order of the volcanic explosions forming the famous crater lakes. People became enmeshed within ecosystems, their land use becoming highly fine-tuned to local environments. With land use practices underpinned by law, there was almost nothing that was not valued. Nothing was nothing. My favourite cookbook is Stephanie Alexander's Thick Cook's Companion, which has around 1,000 recipes. I count the number of vegetables that are used. It's around 120. I then go to Bob Dixon's Linguistic Rainforest People Thesaurus and Dictionary across 10 dialects and count the number of times a plant is noted as being edible. It's 150, and that's not even a cookbook. Perhaps the most remarkable thing about the rainforest diet, though, is that the dominant staples are toxic. When people first came to the wet tropics, the rainforest had retreated, and only about 15% of the Atherton tableland was rainforest. I wish. As the planet tilted out of its glacial phase, the Great Barrier Reef shelf began to flood, starting at 15,000 years ago and being fully inundated 8,000 years. Rainforest too flowed across the landscape in an expanse larger than the pre-European rainforest. People were quick to inhabit them. By 5,000 years ago, tribes of people lived almost exclusively within the forest, but the climate once again shifted to El Nino megadroughts. This time, the people stayed put and galvanised an extraordinary culture based on a staple of toxic nuts. The process of converting toxic nuts into a powerhouse food was intricate and time-consuming, particularly for black bean, Castanospermum australe. Amazingly, the preparation makes the starch digestible. Just one of the nuts, yellow walnut, has 3 times the amount of energy as the equivalent amount of potato. This technology ensured that there was always something to eat, so much food, in fact, that it was enough to cache in wet mud or to stockpile in camps to feed the large wet season ceremonial gatherings. What happens to country when people are taken out of the picture? In the western deserts of Australia, the Martu people were cleared from country in the 1960s, severing in an instant their millennia-long patterning of landscape with gentle fires that created niches for plants and animals. Large wildfires instead incinerated the landscape, and with it the rufous hair wallaby, burrowing bettong, bilby, mulgara and brush-tailed possum. Invasive species, rabbits, cats, camels, foxes and donkeys took over. When the Martu returned in the 1980s, scientists travelled with them to see if they could map Martu knowledge. Emerging from the ashes was a remembered network of thousands of different links based on hundreds of plants and animals, what they ate and what ate them. The Martu showed the scientists how to manage, build and keep the pattern of life connected and strong once again. In the top end of Australia, a pollen record extracted in a core from a lagoon in suburban Darwin shows a dry and cracked landscape at the end of the last glacial 13,000 years ago. Between 9 and 4,000 years ago, rainfall increased with the return of the monsoon. But then, as here, climate shifted to one of El Nino volatility and long droughts. But instead of destructive wildfires, the core shows that even in the face of increasing drought, the landscape filled up with layers of rich vegetation, the likely handicraft of people with an intimate and deep ecological knowledge of managing landscapes to enhance life. It seems these future makers had almost miraculously decoupled landscape from climate. In the wet tropics, the management of fire was particularly fine-drawn, calculated to augment, not diminish, plant and animal cycles with a thoroughness and scale that was breathtaking. The rainforest was traced with pathways and enlivened with thousands of open pockets of sclerophyll, and the boundaries between sclerophyll and rainforest was intricately managed. More than half of the wet tropics is dominated by non-rainforest communities, which are as unique as the rainforest. How Thiaki mourns the profound and instantaneous lack of coevolutionary communication, I can't begin to imagine. The loss of careful management, maintenance, and creation of niches that supercharge life must have left an impact I don't know how to define, let alone measure. In Cloudland, I highlight two pernicious ideologies that ultimately bring down rainforest people and the rainforest. The belief in a chain of being that flowed from God and angels down to kings and queens and Englishmen, down to tradesmen, and then at the very bottom, primitive men and apes. The convenient belief that Aboriginal people were less than human allowed for the horror of the Australian wars. The European fabrication of a yeoman's ideal based on closer settlement brought down the rainforest. Cloudland details this, and here I'll just provide you with a brief vignette. On the 9th of October, 1873, August Frederick Elphinstone Dalrymple, the father of North Queensland, was in raptures on the glorious Johnstone River, where he discovered expanses of taro and apparent plantations of wild bananas. At a particular picturesque site, he found a Mamu people's camp and huts shaded by fig trees and black bean. The camp was swept clean and beaten hard by years, perhaps dance and ceremony. Nearby was moored a small fleet of 20 catamarans, each capable of carrying several people. The next day, Dalrymple invaded the village, bringing up his entourage of 3 boats, including a police boat, working under Sub-Inspector Robert Arthur Johnson, after whom Dalrymple named the river. Johnson sent out his troops to kill people, something he proved expert at, having shot out the populous coast north of the newly claimed Cardwell the year before. The Johnstone is named after a mass murderer. Dalrymple named many of the prominent features of the wet tropics coastline and recorded plentiful red cedar, which set off a cedar rush that spilled over to Thiaki in 1881. In 1882, Cedar Getters were felling huge giants for English cigar boxes. So huge were the cedars that they needed to be split by dynamite to pass through the railway tunnels up the Kuranda Range. In London, they were too big for the English sawmills. This didn't stop Cedar Getters, who hacked down the trees in a frenzied attack, all the more obscene, because at first they couldn't get the logs to market since the railway was nowhere near. They tried the Barron River, so it became clogged and with logs that smashed to splinters when they barreled over the Barron Falls. In the forest around Thiaki, cedar trees were felled and left to rot. So dismissive of rainforest people were the Europeans that virtually nothing is known about them. Naturalist Carl Lumholtz on the Herbert River in 1882 was one of the first who spent any time with people. He was aghast at the uncivilized brutality of the whites, while admiring the rainforest people's poise, skill, and sense of humour. He was enthralled by their intense observational power, something he could never hope to match. They revelled in existence, he said. They also helped him discover 4 new species of mammals, the Lumholtz tree kangaroo, the 3 ringtail possums. At the time, further north, in Herberton, the Barbaran people were almost instantly eliminated when tin miners arrived. In 1882, the government threw open 50,000 hectares of the tablelands under that cherished closer settlement policy of smiling homesteads. The problem was that the rough, mostly uneducated European pioneers didn't have the skills to farm it, nor did they want them. Clearing the forest took effort, and they wanted the quick wealth from gold or to grub like demented wombats for tin. So instead, they employed the industrious Chinese, who had been banished from mining. Chinese rent was lucrative, particularly if the European selector had made money by removing all the valuable timber from their selection after the railway reached Atherton. Propaganda pamphlets issued in 1905 proclaimed that there was room for 4 million white Australians, and a few Chinamen need not frighten them. The industrious Chinese were making the inept Europeans uncomfortable. In 1912, the Chinese were barred by law from agriculture, even though it was only the Chinese that could actually do agriculture. The leases were instead kept aside for soldier settlement after World War I, a scheme which spectacularly failed as city-reared soldiers suffering war wounds and PTSD were reduced to grinding poverty. Most walked off the land or committed suicide. By the 1920s, 100,000 hectares of the Atherton tableland had been selected, of which only 6% were cultivated. Nevertheless, speculators continued their ludicrous braying for more land to be opened. The rough rainforest-clad land between the Russell River and the North Johnstone River at Bunji was opened in 1924. It was rushed by timber getters who lobbied for the opening and then mostly abandoned to weeds. Enter Edward Swain, the pugnacious director of forests. He didn't suffer fools, and in the 1930s, he said that closer settlement was foolish. He pointed out that forestry was also land settlement, and unlike agriculture, it could support the local economy in perpetuity. Anyway, there was no areas left for agriculture. Under Swain's leadership, forestry provided the state government with good revenues, which were not reinvested, because politically, forest management was seen to be against the freedom of the timber getters to operate as they saw fit. Swain railed. It all came to head in the 1931 Royal Commission, Closer Settlement versus Forestry. But with Queensland anti-intellectualism on steroids, the three commissioners selected were chest-thumping close settlement advocates and miners, and the Royal Commission turned out to be an inquisition into forestry. Jaw-droppingly, the commissioners argued that there was an abundance of timber, in fact, too many trees. Clearing the forest for dairy must continue, they said. The issue, they said, was a testing ground for the European race, where white Australia must stand or fall. Swain was sacked. Forest management, they said, was alien to the British instinct of colonisation and to every sound principle of progress. Furthermore, they said, Forestry Department had strangled land settlement because of its unpersuasive idea of providing timber supplies for future generations. So what was it all for? Dairy industry? It was pauperised. For years, farmers paid less for butter and cheese than it cost to produce to help war-torn Britain. A rare sociological study exposed that those with the worst living conditions were the dairy farmers of the Atherton tablelands. What about forestry? The number of trees felled quadrupled after the introduction of mechanical logging. The post-World War II log quota for sawmills was pegged on the maximum quantity of logs that sawmills could take. Perversely, this quota became the sustained yield. There were 1,300 sawmills. In 1966, legendary ecologist and botanist Len Webb was the first to reference the nature conservation value of the rainforest. In 1974, the federal government noted in its first report to the national estate that the wet tropics had been little studied. In 1976, a commune of hippies was raided in Cedar Bay. 12 partially naked and totally bemused people were arrested in a military-style operation. It seems their free-living vegetarian lifestyle had been an ongoing affront to the cow-eating Queenslanders. It attracted national and international media attention, particularly when no drugs were found. Then, in 1983, Joe Bjelke-Petersen, the corrupt Conservative Queensland Premier, threw support behind the bulldozing of a road through the Daintree. The bulldozer drivers had absolutely no idea where to go, and they were met with a group of wiry and determined protesters and the media who documented Queensland's signature police brutality. It was the Daintree blockade. A group of new settlers who had purchased rainforests in the Daintree, not to develop it, but to protect it, found themselves in the front line of the battle for the forests. They would lose the battle for the road and some others beside, but after a decade of exhausting campaigning, Prime Minister Bob Hawke, who needed the environmental lobby to win an election, announced that his government would nominate the wet tropics for World Heritage listing if they got back in, and they got back in. For Thiaki, it was a two-edged sword. The World Heritage boundary is a jumble of 620 properties with a small jutting western peninsula of the Herberton Range that skirts around but doesn't include Thiaki. The owner had had enough of logging and had offered to sell the logged out remnant to the government. He threatened to clear the forest if it wasn't purchased. Satellite images taken in 1992 show a claw-shaped gash emerging on the very steep slopes, punched in anger by his bulldozer. The end of the book takes a modern-day look at ideology surrounding our biodiversity crisis, the Kyoto Protocol and its abandonment of ecosystems, a spectacular own goal served by the warring sides of the environment movement, the carbon wars and the current perverse discord around restoration and offsets. Thiaki will never be able to return to a landscape that existed before European invasion, but 300 million years of living dangerously has given the forest an interesting perspective on the world and a prescience displayed in the miracle of regeneration. Thanks.